The title of my PhD can be summarized into Weather and Hydrological Ensemble Forecast Post-Processing. Weather can be anything from precipitation to temperature, basically everything that you have on your weather applications on your phones. And hydrological can be the inflow into a reservoir with which we optimize the hydrologic generation. I work with ensemble forecasts as opposed to single forecasts because single forecasts cannot convey information about uncertainty, and we are uncertain about our forecast because we simply cannot observe and or model the universe in a perfect way. So take the example of Red River flood in 1997. The forecasters had issued a single forecast of 49 feet for the river peak, and what happened in reality was 55 feet. If they had issued an ensemble forecast, which in nature is probabilistic, the decision makers would know that there is a, say, 90% chance of that 49 feet river peak happening, and there's also a 10% chance of something much worse happening. They would have been prepared, and this wouldn't have happened. So how does forecasting work? You have a model, our understanding of the world, you have the input data, mostly the observations, and then you have the output, the forecast that we want. You can improve on the models with in situ tests, you can improve on the observations with making better devices for taking observations, and you can improve on the forecast with post-processing, which is what I do in my PhD. So imagine you're playing hockey, and you are trying to hit the corner of the goal, but each time you hit the outside of the goal. So next time, on purpose, you try to hit the middle of the goal, and you hit the corner, right? You have detected the error, you have kind of reversed it, and you have done post-processing, just like me. I have a set of forecasts, I have a set of verification corresponding to those forecasts, you know, what has happened in reality for those forecasts, and I find the error. The next time I have a forecast for the future, I apply the reverse of that error, and I get a better post-processed forecast. So, what is the significance of post-processing? It is the last gatekeeper, meaning that if the forecasts are erroneous because of our not perfect observations, or because of our not perfect models, or even when the observations and the models are as good as humanly possible, and there is still errors in the forecast, the post-processor in theory can detect all those kind of errors. Number two, it is a statistical approach, meaning that the nature of your prediction doesn't really matter. You can be predicting the chance of cancer in a cell body, you can be predicting the strength of your concrete, you can be predicting the chance of a snow, or the amount of a snowfall, doesn't matter. The post-processor is like, tell me how wrong you have been, and I will tell you how wrong you will be, and then you can correct it. And my PhD, of course, has a practical aspect as well. We are working with 44 catchments across Quebec, and they are very different in size, in land coverage, etc. And this will enable us to make sure that our post-processes are robust and we can use it for different catchments, different cities, different climates, you name it. And that's it. Thank you.
Thank you.